Okay, we're back. On to the second half of the examples from 5.2. This is the third example we did in class last Friday. So it's going to be, these are going to be a little bit more involved. Secant squared x minus 1 times sine squared x minus 1 should equal negative sine squared x. So one thing you notice is they're negative. Somehow we're going to need to generate a negative. Who knows how that will happen. Another thing you notice is the right side is much shorter than the left, so we somehow have to compact the left. One thought is to FOIL those. That would certainly be an option. That would, though, if you think about it, it's going to generate 4 unique terms, and they're not going to be too happy to be together. So they're going to be 4 ugly terms. So I don't really love that idea. But if you think of compressing, and we see some squared terms with ones, I'm going to think Pythagorean identities. So secant squared x minus 1, that is tangent squared. So with the goal of compressing, I'm going to do that. Sine squared x minus 1 is, I know what 1 minus sine squared is, but what's sine squared x minus 1? You might figure this out, but let's say you don't. You could say, I don't know, so I'm going to replace sine squared with 1 minus cosine squared. I know I can do that. And I still have this extra minus 1 going on here. You could do that. And you'll see eventually that those ones are going to cancel, and you end up with negative cosine squared x, which you may have done right away, and you go, oh yes, because if 1 minus sine squared is cosine squared, then if you flip those, make it sine squared minus 1, you do that by multiplying by negative 1. So the other side would be negative cosine squared x. Try it out, do some algebra, you could test it, or you could do what I did right there. Okay, so at this point, we've done some good compressing. We look to the right, we see, it's still just one term, sine squared, with a negative. And hey, actually, I got a negative out of here, so I'm pleased with that negative in front of cosine squared. What should we do? Well, one thought would be to change tangent squared to sine squared x over cosine. Because, hey, we need a sine squared somewhere. There we got one. And you see pretty quickly here that this is going to be very nice because the cosine squared there will cancel with this one, and you're left with the answer. So you kind of just stumble upon these. I mentioned this in class, but I usually don't know where they're going either, and they just come together. So it just takes practice, practice, practice. Okay, the fourth and final example we did last Friday. Oh, you know what? I just did these out of order, which is fine. But I did the one I just did was the fourth example. If you're looking at someone else's notes, you might be confused, but it doesn't really matter the order I do them. This in truth was the third one I did in class. And this one's really cool. So don't go watch TV. Hang in there. Stay tuned. It's getting good. Right side, you want to make the left side look like the right side, and you notice the left side has a minus. The right does not. We must subtract those two things. How do we subtract? I have no idea what secant x minus cosine x is, but what we can do is change one or both of them to a fraction and get a common denominator. This is going to be a very common move. So which one should we change, or should we change both? Well, secant, I don't like secants. I'm going to change them to 1 over cosine x because I like cosines better. I prefer sines and cosines. In this case, what should I do with this? Well, let's get a common denominator. It's going to be cosine, right? Because, well, let's just do this. This is cosine x over 1. So what's the common denominator? It's going to be cosine. This guy already has a cosine, so you don't have to do anything with it. But the other thing, the next term, this term, needs a cosine down here. So to get the cosine down there, you have to multiply top and bottom by cosine. So the way that's going to work is we're going to end up having cosine squared up here, because cosine x times cosine x will be cosine squared. So again, the term in the yellow circle-ish oval thing there, I multiply top and bottom by cosine x to get a common denominator. I'm really not even looking to the right, honestly, to see what's going to happen. I'm just simplifying the left, and then we'll peek over the right side in a moment. Well, the numerator is something we should recognize. Sine squared x. It's pretty good. Are we done? We look? No, we're not. We have sine x tangent x. I have sine squared x over cosine x. What should we do? We don't want to do Pythagorean identity up top, sine squared, because we just get back where we were before. So at this point, sometimes I think, okay, this, let me get my yellow out. This guy here, this guy here, this guy, there we go. That's sine x. And I have two sine x's on top. So what if I rewrote this and I just put one of the sine x's out front and I left the leftovers here. And when you do that, you stumble upon the final answer you're going to see. If you do that, you'll notice you have sine x times sine over cosine, which is tangent. Let's see if I can squeeze this in here. So my final answer is sine x tangent x, and that of course equals sine x tangent x. We've done it. Again, you kind of just stumble into these. You don't always know where you're going. You just do what you think's best. And one of the common moves is changing the sines and cosines, getting common denominators, and things happen. So keep practicing. Hope this helped.
Made with Doodlecast Pro.